Today I'm going to speak to you about the application of wet areas mapping from a conservation perspective. And while my examples are from work that we have done within provincial parks, please bear in mind that these examples can be applied on the broader landscape. They aren't restricted to parks. I also want to acknowledge two main contributors to this presentation, Matthew Wheatley, who's our conservation biologist based out of Hinton, and Doug Hiltz, a graduate student from the University of New Brunswick. I think it was probably 5 years ago or so that I got this call from this fellow named Barry White, who had this tool called wet areas mapping, and he thought parks might be interested. And I thought, okay, I don't know this guy, but whatever. I'll have him over and we can have a chat. And I think it was 5 to 10 minutes into the conversation, and we were completely sold on the application and use of wet areas mapping in parks management. So just to give you a really brief outline of some of the challenges we have, we are a land manager. Provincial parks are outlined in pink. We are not the wood buffaloes or the Banff or the Jasper, and like a lot of the public, we think we are, but we're provincial parks. So some of our sites are very large, Caribou Mountains, for example, Wilmore Wilderness, and some are very small. We have a dual mandate, essentially, of balancing both conservation and recreation, both from a systems level as well as within individual sites. There are 8 classes of parks currently within our jurisdiction, anything from intensive recreation sites as recreation areas to sites that have the primary focus on conservation, such as ecological reserves and wilderness areas. Each one of those sites has its own constituency, its own management issues. This is a slide from Sylvan Lake, not much conservation value there, mostly recreation, and different contributions to the system, both from the conservation and the recreation side. There are over 458 sites within our system, and they're scattered throughout the province. The plan for parks is really our operational plan. It's a 10-year plan that outlines various outcomes strongly linked to the land use framework, but things like healthy ecosystems and environment and conservation of biodiversity are highlighted, as is the notion of evidence-based decision-making. So using science to inform how we conduct our business and to minimize risk. Some of the challenges that we face is that we have a fairly large land base that we're responsible for. There's increased pressure on that landscape, both within the site as well as external to the site. So you might think of invasive species coming in from the outside, for example. We have very few staff or financial resources. So we have 6 administrative regions within Alberta parks. And within that, there's 1 ecologist per region. That ecologist may be responsible for over 100 sites. As I mentioned, we also have the challenge in trying to balance both the conservation values as well as the recreation within both the site and the system. So we really look to landscape level tools to assist us with managing the landscape. So tools like LiDAR, for example, and wet areas mapping, as I mentioned before. So I'm just going to give you a few examples now of how we've used WAM internally. This is a slide showing William A. Switzer Park, which is just north of Hinton. Hinton, the area, the red dot there at the bottom. Town of Hinton, this is Highway 40 up into Grand Cache, and the green area outlines the boundary of the park. The park itself essentially includes the slopes around a series of wetlands and lakes in a valley bottom. The existing hydrological map that the GOA has is outlined here in the blue. If we just drill in a little further, you can see the existing hydrological information from our GOA sources, the green marking the edge of the park boundary, and the park boundary is in fact delineated on the west side by a rail line. When you superimpose the wet areas map on top of this, you can see that there's much more flow on that landscape than is reflected in the current hydrological information available through the standard GOA. One of the challenges we have with Switzer is we have the rail line, which is in fact impeding flow in a few places. Just drilling in on this site, you can see where the connectivity, hydrological connectivity, has been interrupted by this rail line. So essentially the water is now diverted down the rail line, causing problems for not only the railway, but also the vegetation on either side has changed, and we have interrupted this flow. Given that the wetlands are a huge component of this park, that causes challenges for us in terms of maintaining the ecosystem health of that particular park. So wet areas mapping has provided us with a tool to frame a discussion around how we then get this connectivity connection back. When we are establishing any kind of facility within a park, whether it's a trail, a road, a new campground, we run through an environmental assessment process, and wet areas mapping is a huge component of that. And I want to give an example from Carson-Pegasus Provincial Park, just north of Whitecourt. Carson-Pegasus has a huge recreational constituency. A lot of people go there for boating and fishing. The park itself is delineated by this orange line. We have an existing campground, but there was a proposal for a new campground because of the increased recreational pressure for that site. We had some existing information, which I should say is unusual for many of our parks. Oftentimes we have absolutely nothing, but here we had some vegetation information, so showing that there is a lakeshore community that's very wet. We've got a fen, but for the most part, the vegetation isn't very unique. Pretty standard stuff. When we look at the soils information, again, typically things we don't have. There's mostly luvisols, so this seems like a good place that we would put a campground. We'd avoid the wet stuff. We can then throw on some contour mapping, stay away from the ravines, and stay to the gradual terraces. But when we overlay the wet areas mapping, we can point out a couple of issues. We can see that a few of the campground loops are essentially getting into these areas where the depth to water is really close to the surface. When we look at our existing campground, you can see that we already have problems, and we know that those are problem areas that we have existing. So had we had the wet areas mapping tool before we developed this, we could have avoided the maintenance issues that we've got. So as I say, now we can reconfigure this to minimize the impact to the environment as well as to the people that are wanting to enjoy the campground. We can also use the wet areas mapping as a tool to help work with people that are managing the land adjacent to a park. So when we have a park like Carson-Pegasus that has huge wetland values, a lot of what's happening outside the park influences what's happening inside. So identifying key areas of hydrological connectivity provides us with a tool to work with the adjacent land manager to reduce the impact on the hydrological values within the park. And we've been successful in doing that, particularly in places where there are oil and gas activities adjacent to a park. Just simple reconfigurations of where either the road or the well pad might be placed can significantly reduce the impact on the wetland values of a particular protected area. I'll speak now really briefly about some work that Douglas Hiltz of UNB is doing, trying to look at the relationship between vegetation and wet areas mapping. Doug has two study areas, the EMEND site that Gord just spoke about by Peace River, and then he's also working in Wilmore Wilderness just outside of Grand Cache. And essentially, Doug is trying to look at the depth to water that comes from the wet areas mapping and relate it to soil moisture classes that plants exhibit. So is there a correlation? If we have a plant that has a preferred moisture regime, can we then relate it back to the depth to water that comes from the wet areas mapping? He's corrected for slope and aspect as well as elevation to produce a map for both Wilmore and the EMEND value that essentially just maps the hydrological regime based on the vegetation throughout the park. That may seem pretty simplistic in some regards, but it's been a difficult thing for him to do. And there's huge application for this, because essentially what we can now do is, if we know what the moisture preferences are of particular plants, whether they be a rare species or whether they be a non-native species, we can predict where they may occur. And particularly for the non-natives, we can track where we may have an invasion corridor, the path of movement in a particular area, and that can certainly help minimize the time that we spend in the field in terms of helping us direct where we want to spend our time while we're out there. So one of the projects that I'm working on right now is looking at invasive species in Writing on Stone Provincial Park, just south of Lethbridge on the Montana border. We have a number of invasives that occur in the park, often along that riparian area. And if we superimpose the wet areas mapping on top, you can see there is quite a strong overlap between where the invasives are as well as the wet areas mapping. The blue crosses indicate where we have both Canada thistle and smooth brome, two species that do have a moisture regime that's kind of on the wetter end of the scale, so to speak. So as I say, we're entering into a project right now to test the efficacy of wet areas mapping in predicting where some of these invasive species may occur in Writing on Stone and a couple of other places as well. I'm also going to speak really quickly about some species habitat modeling that Matthew Wheatley has done as part of his PhD work, and he worked on northern flying squirrel as part of that work. And northern flying squirrels are pretty cool for critters. I'm a plant person, but they're pretty cool for critters. They actually feed on the fungi that are associated with trees. He collared a number of northern flying squirrels in the Hinton area, and the red dots indicate where the flying squirrels are foraging in that particular area, so they're definitely in the trees. This is the LiDAR map showing different classes or heights of vegetation, and the darker the color, the taller the tree. So in this case, you can see that the northern flying squirrels are really associated with those taller trees and are avoiding the grassland as well as the shrubby areas. When you superimpose the wet areas mapping, you can see that the northern flying squirrels are essentially avoiding the areas that are wet. They are staying in the drier areas of the forest. Matthew took those type of data, threw them into a model, and was then able to predict where the flying squirrels were and were not occurring on the landscape. So again, information that was helping inform the habitat of this particular species. So I just want to conclude by saying that wet areas mapping is a really valuable tool that we have completely and totally embraced. It helps us with facility planning, whether it's around placements of roads or trails, whether people trails or other types of trails, helping in designing campground facilities, where to place them, how to fine-tune them to minimize environmental risk. It helps with building of habitat suitability models, predictive models for invasive species, rare species. Could be used for a number of other things as well. It's a very cost-effective tool that really does minimize risk. So I really want to end by thanking Barry and folks in Alberta ESRD for helping us with the wet areas mapping, as well as with the UNB crew for doing this. So thank you.